So we're going to continue with 3.1 basic concepts to probability and counting. Again, we've already kind of talked about some definitions on a sample space of a probability. We also have talked about outcomes involving probability. And also, we also mentioned a tree diagram, because a tree diagram helps us see the outcomes and the sample space. But the fallback on a tree diagram is it can be very difficult to draw if your experiment is too big. So we did a couple of examples with outcomes and sample space. So let's move into next thing we got going on, and that's what we call an event. So an event is kind of a subset of the outcomes. So it can be one or more outcomes. So an event that consists of a single outcome is actually called a simple event. So if we have a single outcome, we call that a simple event. So if we look at a coin in a diagram, notice how if we flip the coin one time, there's only going to be one outcome. It could be either a head or a tail. Okay. But now if I do a coin and a die, notice how if we make a tree diagram, and they like to do theirs this way this time, instead of horizontal, we can do it vertically. So notice that if we do, the experiment is flipping a coin and then rolling a die, this is going to be our outcomes: heads 1, heads 2, heads 3, heads 4, heads 5, or heads 6, where you could have a tail 1 through 6. So those are our outcomes. So if we do the experiment one time, only one of those outcomes can happen: heads 1, heads 2, heads 3, heads 4. We can't have more than that. So that's kind of what we call a simple event. Only one outcome is possible. Now, if more than one outcome is, if we have more than one outcome, then we no longer have a simple event. We have just an event. But if we have just one outcome, that's going to be considered a simple event. So determine the number of outcomes in each event, then decide whether each event is simple or not. Explain your reasoning. So for quality control, you randomly select a machine part from a batch that has been manufactured that day. Event A is selecting a specific machine part. Okay, so it says determine the number of outcomes in the event. I don't think we can actually determine the number of outcomes in the event, but we can recognize if it's simple or not. So they don't really give us that actual thing, but let's see what we got here. So for quality control, you randomly select a machine part from a batch that has been manufactured that day. So I guess what we're picking up on is our experiment is we're selecting a machine part. So that's our experiment, is we're just picking one machine part. If we're picking one machine part, then we can only have one outcome, since we're only choosing one. Only one outcome is expected. So event A is selecting a specific defective machine part. So is this event A simple event or not? Well, to me, if you're selecting a specific defective machine part, that sounds like only one outcome can happen. So I would describe this as a simple event. So if you look at this one, if you roll a 6-sided die, the event B is rolling at least a 4. So if you're rolling at least a 4, notice that your outcomes could be at least a 4 would be a 4, 5, or 6. So since the event has actually 3 outcomes, this is not simple. This would be the other side of that. That's going to be not a simple event. So if we have more than one outcome in the event, then it's going to be not simple. So if we want to pause a second here, and let's see if you can look at these next 2 events and see if you can kind of identify if it's simple or not. So I'll go ahead and continue on, but you can kind of pause it if you like there. So you asked for a student's age at his birthday or her last birthday. You determine the number of outcomes in an event. Then you decide whether each event is simple or not. Explain your reasoning. So event C, the student's age is between 18 and 23 inclusive. Inclusive means include the 18 and 23. So that means you have like 18, 19, 20, 21, 22, and 23. So that would be my possible outcomes. Remember, a simple event can only have one outcome. And this has actually 1, 2, 3, 4, 5, 6 outcomes. So this is going to be not simple. So event D, the student age is 20. Well, since there's only one outcome, 20, that's described as a simple event since there's only one outcome. So we have not simple and simple. So we'll stop there.